And I'm going to show you how to do the Molarity lab today. So most of you just finished a quiz, and or perhaps you're absent and you want to watch this video to see how they made a Molarity solution. So first thing you need to know, and I'm going to write this down here, is you guys are going to make a 0.25 mole, let me scratch that again, a 1 molar NaHCO3, okay, also known as sodium bicarbonate or baking soda. Okay, so I'll write those two names down: sodium bicarbonate. Now, some of you have this in your fridge, so it eliminates odors or smells, or the common name is baking soda. Okay, and I believe your teacher wants you to make 25 milliliters of that solution. So how do you go about doing that? Well, the first thing I'm going to show you is your teacher, what they're going to do. Your teacher is going to make a 1 molar solution of hydrochloric acid. Okay, and they're going to give you 18 milliliters is what you should need of that. So I'm going to show you a little bit about this. Now, I went into the stock room, and unfortunately I don't have the 1 molar. I have the 6 molar, which is way too strong. So I'll show you this real quick because this is the next topic that you're going to need to learn. It's called a dilution, and that means just to basically make it less strong. Dilution formula. And the formula is pretty easy. It's just M1V1 equals M2V2. And it means the strength or molarity of my first times the volume of my first solution mixture is going to be equal to the molarity of my second mixture times the volume. So I know I have a 6 molar solution. That's how strong it is. I'm not sure how much I need of it, so I'm going to put X equals, and then I want to make a 1 molar strength solution of the acid for our class, and I know for the entire class I need to make roughly 500 milliliters. So I do 1 times 500, that's pretty easy, that's 500, equals 6 times X, which is 6X. I divide both sides by 6 to get X by itself, and I come up with 83.3 milliliters. So what does that mean? It means I got to take 83 milliliters of this, and then dilute it down with water so that it's not as strong. So I'll kind of show you what that looks like. So I got my 500 milliliter flask. I'm going to take my graduate. Unfortunately, I'm going to grab a bigger graduate, so I'll be right back. So hold on. Alright, so now let's double check that. I've got 83.3. You can verify that amount. I'll rinse my hands off here. Got the.
That is very nice, Mr. Scott.
Is it pretty close?
Well, it's exactly 83.
Some countries.
We're gonna say it's exactly 83.3 when I estimate.
Alright.
Good job.
So now I'm gonna pour this into my 500 milliliter flask. Once again, you can see that it's kind of cool looking. It flows a little bit, say less or more viscous than water does. I don't know if you could tell though. But anyway, now this volumetric flask, what makes it so expensive is this marking on it. This marking is exactly 500 milliliters, and so you're going to fill to that mark with water. And generally, you don't want to use the tap water. You want to use the distilled water. So I know my 8th block was using all of it up, so I'm going to have to fill that up. But I'll see if there's enough to kind of fill this flask here. There might be just enough. Yeah, I feel pretty good about this. And then if I get close, I'll do one of two things. I might just go to the water bottle, which also has distilled water in it. It's gonna be close. Alright, it's starting to get close.
Ooh, ooh, nice.
Don't want to overshoot it.
Wow.
I was lucky.
I mean, that is good.
Yeah, a little luck helps. Alright, so now, magnet, it's kind of cool because, oh, you know what? You're going to be able to see this. It's going to look cool. Look at, you can see the acid and how it has a different density, a little different viscosity than the water. So I'm gonna kick up the notch, and you can see it start to mix.
I like when you use terms like viscosity. It's like you're bringing the physics into the chemistry.
Yeah.
Yeah. Oh,
Love-
look, now it's all kind of uniform.
Whoa.
Whoa.
Get the cyclone going.
Oh, that's really cool.
Yeah, that's pretty wild. So I would say, a minute or two, and it's mixed pretty well.
Meanwhile,
To get that magnet out, you never want to pour the magnet down the drain or whatever. You just get a bigger magnet. Kind of, well, maybe. This is where that luck comes in. Not today. Yep, maybe today. There we go. And then the big magnets out. Now I want to rinse that off. Obviously, I don't want that. So I'm going to pour 18 mils and have that ready. Now it'll be in a little beaker at your lab station. So you'll see it there, so it's a little bit easier to pour. Because I don't want you to pour from the volumetric flask. It's a little tougher. But I know Thor Sizzle can do it. But anyway, I'm going to pour 18 and just have that sitting ready. Okay. And you want to do that on a level surface. I'm just doing it a little bit above level for the camera, just so you can see it a little bit better. So I don't know if that's exact. It might be. I might have shot it over a little bit. So
looks pretty good.
It's pretty close. Okay,
Pretty
good.
close.
So now you're ready for your calculations. Now these are the problems that you've been doing for quite some time. So you should know how to do these molarity questions. So you want 25 mils. Now, first of all, you know that doesn't work in our formula because our formula for molarity is moles over liters. So 25 mils, you got to divide by 1,000 to get liters. So you divide that, that's 0.025 liters. Did I do that right?
Yes, sir.
Okay, good. Just wanted to make sure it never hurts to check. The moles equals the molarity. Now, how strong did I want to make it? I wanted to make it a 1 molar. Just the same strength as the acid. So I solve for this now by multiplying by 0.025 to both sides. And 0.025 times 1, as you know, is 0.025 moles. But you know I can't just go to the scale and measure out moles of this stuff. I have to do a little conversion that we've been working on. And I'm going to put moles of NaHCO3 down here. This is called unit analysis or unit conversions. There's another way you could do it if you wanted to. I added this up off the periodic table. Don't think I just made that up. I just added Na off the periodic table, which is 23, H is 1, 12, and then 3 O's. The other sneaky thing you can do is on the label, I think it tells you somewhere that it's 84 grams per mole. Maybe? Not today. Anyway, some of the labels tell you that. So I multiply that by that, and I find out that I need 2.1 grams of that stuff there. So that's what I need in order to make my solution. So I'm going to go to the scale now, and you'd probably take a scoopula. For real, that's the best name they could come up with for this thing.
Well, I heard they came up with it because it's like a hybrid between a spatula and a scoop.
Really?
Yeah, it's
That's
kind of
pretty
like a spork, you know? It's like a spoon and a fork.
Oh, is that Taco Bell came up with that?
Maybe.
All right, I'm gonna go in there, get my. Now I teared the boat because I want it to say 000, so I don't want the boat to factor in, the weigh boat. So now when I add the powder, I'm just getting 2.1 grams. This fine granular sodium bicarbonate,
Very fine.
and that should do it. I'm just making that up.
Oh, wow.
maybe it didn't.
Whoa. Mm.
Oh, there we go.
Wow.
All right, got lucky again.
The power of positive thinking.
Been on a roll today. So now I'm going to take this and put this in an Erlenmeyer flask. So I got 2.1 there. Okay, and now what would I add? I'm going to add, I want 25 mils of water, deionized water. Now you know I was running thin on that. So let's see if I can get 25 mils out of there.
Do we have any water bottles in here?
Oh, just a little over, but not bad. All right, that's pretty close.
Oh, yeah, perfect.
Okay, good. So I'm gonna add that to my flask. So now roughly 0.1 molar solution here of sodium bicarbonate, not 0.1, 1 molar solution. And then in your in your graduated cylinder here is 1 molar of hydrochloric acid. So this is new to us. We're going to be studying pH, but this is called an indicator. This is bromothymol blue. And in the presence of base, it should be blue in color. So I didn't swirl it very good.
While you're swirling, I'm going to go grab the lab, so we'll pause.
Bromothymol blue. I'm going to add, I believe it calls for 5 drops into my Erlenmeyer flask. So, boom, 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 boom. Generally want to hold it straight up and down. All right, swirl it. And as I mentioned, it's got a blue color in the presence of base.
And all this information is in your background, okay? So it's a pH indicator. If it's acidic, it has a pH less than 7 and it'll be yellow, but our solution is blue, so that means it is basic. Okay, blue. So we want to neutralize it, make it like water, have a pH of 7, and we want it to turn green. So when an acid and a base come together, they should neutralize one another.
All right, so I'll leave that on the white paper. It's a nice little visual. Right here is where you're going to do your calculations that I just did to get that 2.1 grams. It's good for you to practice.
So while
Make sure
it's
you
kind
can
of
do that.
all swirling, make sure that you can catch up, okay, with all your calculations. You might want to pause the video, catch up, do whatever you need to do.
Which reminds me of a joke. Mommy tomato, daddy tomato, walking way up top, you know, they're at the Woodfield Mall. They look back, dang little baby tomatoes, you know, sitting there straggling behind. And dad is getting so frustrated. He looks at the mom, goes over right to the baby, and smash, smash, smash. He goes, now catch up. Okay, sorry, I don't know where you lost me there. Okay, now we're gonna take our acid. This is 1 molar. We're gonna add it right into just a little at a time. Whoa, look at
Whoa.
those fancy bubbles.
We got bubbles.
Okay, all right, and then just a little at a time.
Bubbles. So those bubbles,
Whoa, yeah, I'm noticing the color.
I think that's a little CO2 happening.
Oh, carbon dioxide.
Whoa,
Whoa,
so
look
this
out.
is why you really got to do it slowly. And you can see colors changing.
Yeah, it's definitely going to a light green now.
Oh yeah. Oh.
Whoa.
Whoa.
And then we've got almost a little greenish tint, a little yellowish tint, a little green.
I think it's green.
You got a nice green tint to it. Yeah, very good.
Oh, that's your hand. Yes, it is definitely not yellow. That's
Okay.
green.
Awesome.
Good job.
So now we've kind of neutralized it, and there's a few questions that go along and ask you about neutralization. And we'll get into pH more. Once again, this was an indicator. This is bromothymol blue, and in the presence of acid, it'll go yellow. In the presence of base, it'll go blue, and if it's right in the middle, it'll go green. So there you have it.